Hey everyone, today I want to ask a question. Is nutrition science really science? Sounds like a funny way to begin the talk, but it's really important question. So yesterday we talked about human history and specifically what separates humans, animals, from other animals. Uh, Sorry, let me just wear my microphone. Um, as I mentioned yesterday, there are lots of answers to the question, right? So lots of answers to the many things that distinguish humans from other animals, right? But one of those answers, and for me, I think the first answer is something called culture, right? Humans don't have a lot of natural abilities. What we have is cultures, and through the cultures, we have knowledge, right? So every culture, I would argue, has its own knowledge system. Now, of course, cultures aren't isolated, and knowledge systems feed on and learn from one another. But there are many kind of knowledge systems. So to put it in language that everyone can understand, Western medical science has a certain knowledge system, and Chinese traditional medicine, TCM, traditional Chinese medicine, has another knowledge system, right? And that doesn't just mean that they're mutually exclusive. One can learn from the other. A lot of ideas in Western medicine were probably borrowed from Chinese medicine, but they are distinct, right? Now, when we think back at our history, the most fundamental kind of knowledge was around how to find water, how to find food, and so on. And when we think about early humans as hunters, which is what all the evidence indicates, they had to learn how to break a stone in such a way to create, for example, a spearhead, right? Now, by the time we get to Homo erectus, who was hunting mastodons and mammoths, big elephants, right? The knowledge system would have been about how to trap an elephant, how to make a trap for an elephant, or how to carve wooden spears, or how to make stone tips, et cetera, right? Now, let's use that example to ask the question, okay, what is science? Think in terms of the stone tip of a spear. So I need to understand, in order to make that, I need to understand that, I need to sharpen a certain stone. And I need to, if I do that and attach it to a piece of wood that's cut a certain way, I can throw it, and then I can, with luck, I can kill an elephant, or I can defend myself against a lion, and so on and so forth, right? Now, in the very beginning, of course, there would have been trial and error. So I made something that didn't quite work, et cetera, et cetera. But once I sort of get the hang of it, now I'm formulating a hypothesis. My hypothesis is that every time I cut a stone in this certain way, I can use it as a weapon, right? And I'll get the same results again and again and again and again. But one day something will happen. So that replicability is really the key of what we're talking about. But one day something is going to happen, and I'm going to try to, maybe I've trapped the elephant, maybe I try to kill the elephant with a spear, and the spearhead is going to break, right? The stone is going to actually break. Now I said, look, that means that I have to, if I survive the experience, which is a whole different story, but assuming that the person who did that survived the experience, now they have to refine their hypothesis. It's not just any stone. It needs to be a stone of a certain hardness, needs to not have any imperfections. Ideally, it needs to be made of something called flint, et cetera, et cetera. So in this way, the scientific method can progress. We formulate a hypothesis, and then we try to disprove it, right? And it does get disproven, right? And when it's disproven, then we have to refine our hypothesis. We have to make it more and more specific. Not just any stone, not just any wood. These are the best stones. These are the appropriate stones. These are the stones which will not work, right? You can have many, many hypotheses coming out of this, right? So what about nutrition science in particular, right? Now, unfortunately, when you look at the history of nutrition science, it doesn't have anything like this, right? You don't have, actually, you did have at that time, you had largely vegetarian populations in some parts of Africa and Asia, and you had largely meat-eating populations in, say, the Arctic or in other parts of Africa. But it doesn't even ask that. It takes some assumptions, right? So when we look at the history of modern nutrition science, you find that a point of origin is the so-called Seventh-day Adventist movement, which out of the US, which advocated for a certain way of looking at the world, a theological way of looking at the world, and argued that for moral reasons and for religious reasons, eating a diet of, I think, fruits, nuts, and grains, I want to say, was the only ethical or the more ethical thing to do. Now, if you look more deeply, you'll find that the woman who propagated these ideas, I think her name was Ellen G. White. She never actually ate that diet herself. She never was able to do it completely, but she advocated for that kind of diet all the time, right? So the problem is, if you have that hypothesis, and then you are trying to say, oh, no, vegetables are healthy, and you're trying to manipulate the data in order to do that, you will certainly be able to do that, right? It's like as if I'm here in South Africa and I want to say, look, the bird is that creature that flies, right? That's what a bird is. I'll certainly be able to say that for a certain amount of time. But I may run into an ostrich, which is a bird that doesn't fly, and then I have to revise the hypothesis, right? So my problem with modern nutrition science is there is no attempt to disprove the hypothesis. And in fact, when we look at some things that are accepted as true, I've given the calories example in the past, let's use that as a starting point. So the hypothesis in that is calories in, calories out. Your mass, you will be able to gain or lose mass depending on whether you're burning, well, quote unquote burning. You don't burn a calorie. You don't eat a calorie either. That's a different story. But let's take it as they present it. If you burn more calories than you eat, consume, you will lose weight, right? Now the problem is there are classes of people, and this is not controversial, like type 1 diabetics, for example, who are untreated. If you don't give that person insulin, you can feed them 5,000 calories, again, all in quotes, per day, and they won't gain a pound. It will be impossible. They'll be losing weight, in fact. So that hypothesis just disproves that notion, right? And similarly, there are other people. So, for example, you can come here to Africa, not far from where I am, and you will find that there are communities of people who are not particularly well nourished, and where, unfortunately, teenagers and adolescents can't meet some of their nutritional needs, or even in Bengal, in West Bengal, in East Bengal, Bangladesh, and so on, the so-called hunger belt in Northeast India, Nepal, and Bangladesh, you'll find people who are not meeting their calorie needs, and still the children grow. They gain weight, right? So when you find those counterexamples, there are two things you could do. A good scientist would reject the hypothesis, or at least refine the hypothesis, and say, no, in this circumstances when calories make sense, and otherwise it doesn't make sense at all. Bad scientists, which is what we seem to have everywhere, double down and find excuses for the reasons that their hypothesis doesn't work in certain respects, right? I think the lipid heart hypothesis is another example where again and again we find data showing that actually low LDL, low ApoB is far more dangerous than high ApoB. This is, by the way, this is out of the context of medications. So I was having this argument with a cardiologist in the lean mass hyperresponder group, and that person said, no, look at this study. The study was in drugs. I'm not talking about drugs. I'm talking about free-living people. We find that low LDL is a huge risk factor for all-cause mortality, right? That's just a fact, right? So when you have those kind of facts that are going against, your hypothesis, again, a meaningful scientist would reject the hypothesis. Now, people will then turn around and say, well, Samir, you're also using a hypothesis. I say, yeah, I'm using a hypothesis, but my hypothesis, I know what it would take to disprove my hypothesis. And I'll tell you that in a second. But before I tell you what it would take to disprove my hypothesis, you tell me what it would take to disprove the lipid heart hypothesis. Are there populations where LDL does not track with heart disease? Sure. Are there populations that have a very low LDL and have a high risk of heart disease and high all-cause mortality? Yes, absolutely. So when you have those things, are there trials showing that, for example, the Minnesota coroner, the Minnesota heart experiment, which showed that yes, we were able to lower LDL, but heart disease and all-cause mortality went up. Absolutely, and that was in the kind of study that's not ethical anymore, right? Because it was done in basically an imprisoned population in an asylum, right? So if you have all those things and the LDL hypothesis, the lipid heart hypothesis is still not disproven, then you tell me what it would take to disprove the lipid heart hypothesis. And until you can tell me that something is falsifiable, that's another key principle of the scientific method and what it takes to do real science. Unless you can prove to me that something is falsifiable, it's not a hypothesis. It can't be said, right? So my hypothesis is simply that humans, like all animals, will do best, or the default assumption should be that humans will do best on the diet that they evolved to eat, like any other animal, right? That is my only hypothesis. Then the question becomes, okay, what is the diet you evolved to eat? Well, that's going to, we have the scientific data which is showing, based on the collagen analysis, nitrogen isotope analysis of the collagen in fossilized long bones of early humans, we can find out that humans were what's called hypercarnivores. They were getting more than 70% of their calories from meat, maybe from fish in certain areas, and so on, right? So what it would take to disprove that, I mean, you have to show me evidence, a lot of evidence showing that my understanding of the nitrogen isotope analysis is wrong, right? That's one thing. But what you, or you'd have to show me like really good like really good clinical trials, long-term clinical trials in genetically matched populations, showing, on a variety of diets, showing me that X diet is better than the diet that we can figure out that humans evolved to eat, right? That's very difficult to do. That's not, like I say, it's not ethical. It's not going to happen. So that second thing is not going to happen. But if it were going to happen, if it were to happen, then I would be happy to accept that as scientific proof, right? So this is why we have to distinguish between the scientific method and what I think genuine science is, and unfortunately nutrition science, which is a whole different thing. Now there is other things have come up in terms of what about traditional allopathic medicine and so on. I think that's a conversation for another day. We can't really say. So all of those trials need to be taken for what they are. But let's just say that I think people put too much faith in some of these things, and the word science is used as a code word for this is right. This is scientific means this is right. No, it's not always correct. So thanks. I see someone called Saima Ishtiaq is in there. Hi, Saima. I've sent a comment. Okay, I will respond to comments when I see them. I don't have time to check them every day, but I'll get back to you soon, Saima. Thanks so much for everyone's time. I've really been enjoying reading some of your comments. I know many of you don't see this live, but whenever you do see it, do leave me a comment. I'd love to hear what's going on. As some of you will know, we have a deadline today. We're closing admissions for the first round of the Healthy Heart Blueprint. It's not the first round, actually. We had a sort of beta testing round, and people actually absolutely loved it. So if you're at all interested in taking the step to improve your heart health, your health overall, the invitations are extended. The application period is open. Drop me a line. I'd love to hear from you. Thanks, and I'll see you in the next one.